What if I told you that the most powerful airborne radar in the world, the one they call the eyes of the entire Air Force, could become blind? And that its main vulnerability is not in its engines or electronics, but in a simple law of physics you learned in school. Today, we are breaking down the E-3 Sentry AWACS, why it is called the eye in the sky, how it works, and how it can still be detected. Subscribe to the channel if you want to see the real physics behind military technology, not just loud headlines. And let's begin. What is AWACS and why it matters? AWACS is not just an aircraft, it is a full airborne command station, airborne warning and control system, literally a flying control tower. Imagine an airport control tower in the world's largest airport. Now lift that tower to an altitude of 9 kilometers, make it mobile, and give it the ability to see not just 100 kilometers, but 400 kilometers in all directions. That is the E-3 Sentry. This aircraft was designed back in the 1970s, but it remains a key element of air power today. Why? Because without it, fighters are like boxers with blindfolds. They can throw punches, but they cannot see where the danger is coming from. The E-3 takes on the role of eyes. Its famous rotating dome above the fuselage is not a communication antenna, it is a passive electronically scanned array radar. It rotates at 6 revolutions per minute and scans the space around it. How the E-3 radar works. Let us go a bit deeper. That dome is not just round. Its diameter is 9.5 meters, its thickness is nearly 2 meters. Inside is an antenna that emits radio waves in the range of 1.5 to 2 centimeters. This is the so-called EF band or S band in oldie terminology. These waves reflect off aircraft, off the ground, off clouds, and the computer on board the E-3 filters out noise and shows operators a clear picture: who is flying where, at what altitude, at what speed, and most importantly, friend or foe. The detection range for large targets like bombers reaches 600 kilometers. It sees fighters from 350 to 400 kilometers, and cruise missiles flying low over the ground roughly 250 kilometers. But there is one detail, and that detail is the key to answering the question, how can AWACS be detected? The main vulnerability: emission. AWACS is not a passive listener, it actively emits, very powerfully. Its radar is not a flashlight, but a searchlight that reaches hundreds of kilometers. And any modern electronic intelligence aircraft, any ground-based passive direction finding station can detect that emission. More than that, they can determine the direction, power, and even the type of radar. Imagine you are in a dark room shining a powerful flashlight. Yes, you see everything around you, but anyone outside that room also sees your light and knows where you are standing. This is the main physical problem of all airborne early warning and control aircraft. The more powerful your radar, the better you see targets, but the more visible you become to passive systems. And here is another important point. Modern passive location systems can not only detect the signal, they can identify the aircraft by its radar fingerprint. Because every radar has unique modulation characteristics, frequencies, pulse durations. And when you know which aircraft is seeing you, you can start taking countermeasures. What about stealth technology? People often ask, why is AWACS itself not built with stealth technology? Then it would be harder to detect. The answer is simple. Stealth and a powerful radar do not mix well. For an aircraft to have low radar visibility, its shape must be special. No external stores, flat surfaces, special coatings. And that huge rotating dome is a perfect reflector. It cancels out any attempt to reduce radar signature. Moreover, the E-3 is an aircraft from the early 80s. Its platform is the Boeing 707. That is a passenger airliner that was never designed with stealth in mind. But even if engineers created a fully low observable AWACS aircraft, it would still emit its radar signal, and that signal would still be visible to passive systems. Therefore, AWACS will never be invisible. Its job is not to hide, its job is to see first and control the air battle from a safe distance. How adversaries can detect AWACS. Now let us talk about how detection systems can determine the location of such an aircraft. We will not discuss specific incidents or countries, only physics and technology. The first method is passive direction finding, already mentioned. 2 or 3 ground stations placed at a distance from each other measure the time difference of arrival of the AWACS radar signal and calculate its position. This works even if the aircraft does not see you, for example, because of terrain masking. The second method is using low-frequency radars. Typical fighter radars and air defense systems operate in the centimeter band, but there are also meter wave and decimeter wave early warning radars. They have low accuracy and cannot guide a missile, but they are excellent at seeing large targets, and the E-3 is a very large target. Its wingspan is 44 meters, length 46 meters. That is like a 3-story house with wings. Such radars are not affected by stealth coatings. They see the aircraft not by reflection from the skin, but by resonance on structural elements, wingtips, tail, antennas. And they can detect the E-3 from 200 to 300 kilometers away. The third method is space-based reconnaissance. Electronic intelligence satellites in low orbits can detect radar emissions anywhere in the world, and if AWACS turns on its radar, its signal can be picked up by a satellite. But it is important to understand, detection is not the same as targeting. To guide a missile to a target, precise tracking is required, and that is much more difficult. What this means for the future of AWACS. So we have established that the E-3 Sentry was never invisible and never will be. Its main strength is detection range and command capability. Its main weakness is its own emission. So, what are designers doing? The newest next-generation AWACS aircraft replacing the E-3 is called the E-7 Wedgetail. It is based on the Boeing 737. It has a different antenna, not a rotating dome, but a fixed electronically scanned array, ESA. Such radars can change beam shape, switch between modes, and, crucially, use low probability of intercept techniques. They can operate in modes where the signal is spread across a wide frequency band, making it much harder for passive systems to detect. But the emission problem cannot be fully solved. As long as the radar is working, it reveals itself. So the tactical solution remains the same. Turn on the radar only when necessary and change position after each session. This is the reality of 21st century aviation. Nothing is completely invisible. There is only smart risk management, good tactics, and understanding of physics. If you want to understand military aviation not at the level of loud headlines, but at the level of engineering and physical principles, subscribe to this channel. We do not scare you with breaking news. We show you how things actually work. Like this video if you want the next one about the E-7 Wedgetail, a comparison of 2 generations of flying eyes. And I will say goodbye. See you next time in the sky, which we study from the ground.